The Sun, our very own star, has a captivating story that spans billions of years. It began billions of years ago, in a time when the universe was still young and full of potential. Imagine a vast, swirling cloud of gas and dust stretching across the cosmos. This immense cloud, known as a nebula, was the birthplace of our Sun, a stellar nursery. Over time, gravity began to pull the particles within the nebula closer together. The cloud started to collapse under its own weight, a process driven by the relentless force of gravity. As it collapsed, the cloud began to spin faster and faster, like a figure skater pulling in their arms. This rapid spinning caused the cloud to flatten into a disc shape, with most of the material concentrated in the center. The center of this disc became incredibly hot and dense, a cauldron of intense energy. In this central region, where temperatures and pressures soared to unimaginable levels, nuclear fusion began. Hydrogen atoms collided and fused to form helium, releasing immense amounts of energy in the process. Our Sun was born. The birth of the Sun was a dramatic and awe-inspiring event, a new star lighting up the cosmos. This event marked the beginning of our solar system as we know it, setting the stage for the formation of planets. The remaining gas and dust in the disk eventually coalesced, coming together to form the planets, asteroids, and comets. All these celestial bodies were held in orbit by the Sun's powerful gravity, creating the dynamic system we are a part of today. The Sun sits at the heart of our solar system, acting as the central anchor around which everything revolves. It is a giant ball of hot, glowing gas, radiating energy across the vast expanse of space. The Sun is mostly composed of hydrogen and helium, the two lightest elements in the universe, which fuel its nuclear reactions. Its immense gravity holds everything in our solar system in orbit, creating a cosmic dance that has persisted for billions of years. From the smallest asteroids to the largest gas giants, every object is influenced by the Sun's powerful gravitational pull. The Sun's gravity is what keeps Earth in its orbit, ensuring our planet follows a stable path around it. This precise orbit allows our planet to receive the perfect amount of light and heat, creating the ideal conditions for life to thrive. The Sun's gravitational influence extends far beyond the orbits of the planets, reaching out to the distant edges of the solar system. It shapes the entire structure of our solar system, dictating the paths of comets, asteroids, and even distant dwarf planets. The Sun's gravity is a constant force, an ever-present influence that maintains the order and stability of our cosmic neighborhood. It is a reminder of the delicate balance that keeps our solar system in order, a balance that has allowed life to flourish on Earth. Without the Sun's gravitational pull, the planets would simply drift off into space, lost in the vastness of the cosmos, highlighting the Sun's crucial role in maintaining the harmony of our solar system. The Sun, like all stars, has a life cycle. It is a journey that spans billions of years, marked by dramatic changes and transformations. It is currently in its main sequence phase, a period of stability and balance. This is the longest and most stable part of a star's life, where it spends the majority of its existence. During this phase, the Sun fuses hydrogen into helium in its core, a process that sustains its brightness and warmth. This fusion process releases the energy that lights up our solar system, providing the heat and light necessary for life on Earth. However, the Sun's hydrogen fuel is not infinite. It is slowly but surely being consumed. In about 5 billion years, the Sun will exhaust the hydrogen in its core, marking the end of its main sequence phase. It will then enter a new phase of its life cycle, transitioning into a more unstable and dramatic period. The Sun will expand dramatically, becoming a red giant star. Its outer layers will swell, reaching far beyond its current boundaries. As a red giant, the Sun will engulf Mercury and Venus. Earth, too, will be affected, becoming uninhabitable due to the intense heat and radiation. Eventually, the Sun will shed its outer layers, creating a beautiful planetary nebula. It will leave behind a small, dense core called a white dwarf, a remnant of its former glory. This white dwarf will slowly cool and fade over billions of years, gradually becoming a cold, dark ember in the vastness of space. The Sun is the primary source of energy for Earth. This energy drives almost all life processes on our planet. Plants use sunlight to produce food through photosynthesis. This process releases oxygen into the atmosphere. Animals in turn rely on plants or other animals that eat plants for energy. The sun's energy also powers Earth's climate system. It drives the water cycle, weather patterns, and ocean currents. The sun's energy is essential for life as we know it. It is a powerful force that shapes our planet and sustains all living things. Since the dawn of humanity, people have looked up at the sun in wonder. Ancient civilizations recognized the sun's importance for life and warmth. They developed sophisticated methods for tracking its movements across the sky. Ancient astronomers built observatories and monuments. These structures helped them to predict solstices and equinoxes. These events marked important agricultural and religious dates. Civilizations like the Egyptians, Mayans, and Chinese developed complex calendars based on the sun's cycles. These early astronomers made remarkable observations about the sun's path. They laid the groundwork for our understanding of the solar system. The sun's power and importance inspired countless myths and legends. Across cultures, the sun was often personified as a deity. These sun gods and goddesses were typically associated with light, warmth, life, and creation. Ra, the Egyptian sun god, was worshipped as the creator of the universe. The Greek god Helios rode his chariot across the sky each day, bringing light to the world. In Norse mythology, the goddess Sol drove the sun chariot, pursued by a wolf that threatened to devour her. These myths reflect the deep reverence that ancient cultures held for the sun. They recognized its vital role in their lives and beliefs. The invention of the telescope in the 17th century revolutionized our understanding of the sun. Galileo Galilei was among the first to observe sunspots. These are dark, cooler regions on the sun's surface. He also observed that the sun rotates on its axis. Over the centuries, telescopes became more powerful. Scientists could study the sun in greater detail. They discovered the sun's atmosphere. They learned about solar flares and coronal mass ejections. These observations provided crucial insights into the sun's behavior. They helped scientists to understand its impact on Earth. Section 8. Unveiling the Sun's Secrets, Modern Scientific Breakthroughs. Modern science continues to unravel the mysteries of the sun. Spacecraft like NASA's Parker Solar Probe are designed to study the sun up close. These missions provide unprecedented data about the sun's atmosphere, magnetic field, and solar wind. Scientists are also using sophisticated computer models to simulate the sun's interior. These models help them to understand the processes that drive the sun's energy production and long-term evolution. These advancements in technology and modeling are constantly refining our understanding of the sun. They are revealing its secrets with incredible detail. Section 9. The sun's fury, solar flares, and their impact on Earth. While the sun sustains life on Earth, it can also pose threats. Solar flares are sudden bursts of energy from the sun's surface. These eruptions release vast amounts of radiation and charged particles into space. When these particles reach Earth, they can disrupt satellites, communication systems, and power grids. They can also create stunning auroras or northern and southern lights. Understanding and predicting solar flares is crucial for protecting our technology and infrastructure. Scientists are constantly monitoring the sun's activity to mitigate the risks posed by these powerful events. Section 10. The Future of the Sun, a glimpse into our solar destiny. The sun is about halfway through its main sequence phase. In about 5 billion years, it will begin to run out of hydrogen fuel. It will then expand into a red giant star, engulfing Mercury and Venus. Earth's fate is uncertain. The sun's expansion may push Earth into a wider orbit, sparing it from being engulfed. However, the intense heat and radiation from the red giant sun will likely make Earth uninhabitable. The sun's eventual demise as a white dwarf marks the end of our solar system as we know it. It is a reminder of the vastness of cosmic time and the ever-changing nature of the universe. Section 11. The sun's enduring mysteries, unanswered questions. Despite centuries of study, the sun still holds many mysteries. Scientists are still trying to understand the mechanisms behind the sun's magnetic field. They are also investigating the processes that heat the sun's corona to millions of degrees. The sun's behavior can be unpredictable. Scientists are working to improve their ability to forecast solar flares and other space weather events. The sun's remaining secrets continue to intrigue and challenge scientists. They drive ongoing research and exploration. Section 12. Our star, a source of wonder and inspiration. The sun is more than just a star, it is a source of wonder, inspiration, and life itself. From ancient myths to modern science, the sun has captivated humanity for millennia. Its energy sustains us, its light guides us, and its mysteries continue to inspire our curiosity. As we continue to explore the cosmos, our understanding of the sun will undoubtedly deepen. Yet, its fundamental importance to our existence will forever remain a source of awe and appreciation. The sun, our star, is a testament to the beauty, power, and enduring mystery of the universe we inhabit.